Hey, this is Eric. So I've got another VCV Rack tutorial for you. I got a couple of questions, and we'll cover both of them in this one. So the first question was some tips and information about how to do generative patches, which I can absolutely show you. And then the other one was a fairly simple question, how to get stereo out of VCV Rack, which isn't hard to do, although it's not true stereo, but that's true stereo is really hard to do in Eurorack for reasons we'll get into later. So without too much further ado, let's get into Rack. But first, just because I like Bo, a sip of the coffee. All right. So as you can see, we're in Rack. We are in 0.4.0, so that's the brand new one. It just came out a couple days ago. I covered... I've got another video in the works, just covering some of the differences and the new stuff from 0.3.2 to 0.4.0. Overall, great change, some really cool stuff. But all of these techniques that I'm going to show you, I actually figured out in 0.3.2. So you're not going to if you're stuck in 0.3.2 for whatever reason, or for whatever reason you can't upgrade yet, all of this will still work. So let's get started. First things first, let's talk about stereo. What is stereo? Well, stereo is really two mono channels. It's going, one goes to the left, one goes to the right, and that's it. That's all stereo truly is. Yeah, there's some psychoacoustic things you can do by, putting things in between and adding reverb and doing all kinds of stuff that makes the stereo field sound big and expansive and all of that. But truthfully, stereo is just two mono channels, and almost everything in the Eurorack format, and in this case in VCV Rack, is mono. So how do we get stereo from mono? The really dead simple stupid way, and this is the way I do it, is throw a multiples over here by our audio output, and then take your mono input. So I'm going to throw a VCO on here just so we have something. Pop it onto the input, take the output to output number 1, take another output to output 2, and there you go, that's stereo. Now, the one thing you probably want to do, and I'm going to do real quick because we're going to use this patch for our demonstration today, I am going to go ahead and add in a mixer so I can have some adjustment of the levels. But all we're going to do is, let's put it in the right place. There we go. But as you can see now, you get stereo, and it's the same. It's kind of faked stereo, right? It's mono, so it's the same signal to both sides, but your brain interprets that as stereo. If you really want to, you can put different stuff to output 1 and a different mixer go to output 2, and you can have things on separate sides. But in terms of doing like true panning like you would do on a mixing board, you're not really going to get that with this. Now that is really up to the modules that are created for this. Someone could easily make a stereo panning module. It would have 2 outputs, and some of the Audible stuff, I'll show you real quick, does have stereo ins and outs, but I think my understanding is, and I could be wrong, but my understanding is you've got an in left and an in right and an out left and an out right, but I do believe they're processed independently, so it's not like you've got a left and a right here that, where you can pan or do anything real, what you would consider stereo processing with it. You're really going to just kind of put something in the left, you're going to get some modified output from the left output. Same thing with the right. They might as well be labeled 1 and 2 rather than left and right, as far as I can tell, because I don't think you get anything on the right output when you put something in the left output only. So that's kind of that in a nutshell. But the dead simple way to do stereo is to throw your final mix into a multiples, and then grab 2 outs, and then go to outputs 1 and 2. That's the easy way. So we're going to keep this VCO, because we're going to get onto some generative stuff and kind of some techniques you can use. And then I'm going to pull up I did a generative patch in VCV Rack 032 that I will show you later. We might edit that out, we might not. But what I'm going to show you now is the technique, the basic technique to get some like random output from whatever you're working with. From say a VCO. So the first thing we're going to do is I'm going to go to fundamental here, and I'm going to bring in a seek 3. And we're going to just pop the gate on here, and I am going to throw a scope up real quick, just so you guys can see what I've got going on. So this has a gate. Let's put the time down a little bit. And come on, gate. Maybe I want continuous. There we go. That's what we were looking for. This is just a regular gate signal. Very simple, very straightforward. But we are going to use this to do some stuff with our VCO. So the first thing we're going to do is we're going to throw on here, just so we have kind of a synth voice. We're going to go here. We're going to put a VC, let's see, an ADSR on this. We're going to pop the gate into the gate input. And then we are going to put a VCA on this. And we're going to come out from here. We'll go to the exponential. So now you've got your VCO hooked into the input of the VCA. Your ADSR is hooked into the exponential input, which means it's going to be acting as an envelope. And then we're going to take the output here. We'll pop it into our mixer. And as you can see, we have a simple synth voice that repeats every time. Right? And we can mess with the, we can mess with the attack. We can mess with the decay. We can do whatever we want to with it. But it's a real simple synth voice. I might throw it on like saw, just so we get a little more bite. So, how do we start making this more generative? Well, the first thing we can do is we're going to add, under audible instruments here, I'm going to pull the volume down a little bit. There we go. Under audible instruments, we're going to add a Bernoulli gate. And what does this do? Well, we're going to put our gate signal into it. And right now, let's do one quick thing. I'm going to put a multiples here. So now we can take our gate, put it into the input of the top multiples. Now we got 3 outputs from that gate, so I can use it in multiple places. So we're going to put 1 into the Bernoulli gate. I'm going to put 1 into the X input on my scope here. And then we're going to take the output and I'm going to toss it into the Y input. So see, the Y is the purple. We only get Y every so often. And that's adjustable with this knob here. So see, we got one there, but we're getting a bunch of gates and Bernoulli gate here, or a bunch of gate signals, I should say, from the Seek 3. And the Bernoulli gate is blocking a bunch of them. Well, what does that mean? Well, that means that if we come from the Bernoulli gate and we go into the gate input of the ADSR, we're not getting this every time it triggers. We're basically getting a random distribution of, so we get a couple of triggers in a row, then we'll get a break. Then we'll get a couple more triggers, then we'll get a break. So now you've got random triggers. And of course you can mess with this, right? You can increase your chances of a trigger by increasing the clock, right? Or decreasing the clock. You can make it, longer periods between actual triggered gate signals. So now you've got this randomized trigger. What if you want to randomize your pitch? You've got the volts per octave here. So what you would do, or one way to do that, is we're going to add an LFO. Now, a normal LFO is going to give you a weird kind of sound, and so every time we get a trigger, any day now triggers. Now we can turn this all the way down and get all triggers if we want to. I think. Oh, there we go. Okay. I think the LFO was too low to really hear. So, now, you hear the LFO is constantly modulating the frequency that VCO1 is going to put out. We don't necessarily want that, right? I mean, that's an interesting sound, but you don't necessarily want that. But what do you want? Well, maybe what you want to do is get a constant tone each time we get a gate. So check this out. We're going to put in a utilities module, and it's got a sample and hold section down here. So what are we going to do with that? We are going to take the gate output, we're going to pop that onto the trigger input. We're going to take the LFO's output and pop it onto the input. We're going to take the output from the sample and hold and pop it onto the VCO1. Now, one thing you're noticing is we're actually getting tones that are outside the range of hearing because this is going back and forth in too wide of a range. It's only going up. So one of the things what we can do real quickly is we can throw an attenuator on it. So here's the attenuverter. We're going to throw that on the input. And now we've got some control over how much of the LFO gets through. So now we're getting random tones, and we can make them come through at random times. So now if you want to make this like a really spooky ambient landscape, you kind of throw in a couple more things, like maybe a spring reverb, and we'll throw in a delay. And let's see. That's not a delay, that's an LFO. How did I manage that? Try that one more time. Delay. There it is. So we'll go out from here. Whoops. Try that again. Out from here to the input there. Out from here into the reverb. Out from the reverb mix into channel 1. So there you go, like instant ambient weirdness, right? So I'm going to show you another technique, but it's hard to do here. or it's hard to do live, but essentially, I have one of these. This is a tuner. It's just a Korg. It's like a standard, it's basically a guitar tuner. And one of the things you can do with this is, let's say you want these tones to be a little bit more scalar than what we're getting out of this, because the LFO is just basically driving it's driving the frequency of the VCO, which just kind of, it's just a sine wave that's going, and you're just catching it at random points, so you're not necessarily getting something that's in a scale that's, so if you want to make something a little bit more musical and a little bit less atmospheric, and there's nothing wrong with this is super cool, but it doesn't maybe have the same effect as a scalar kind of thing. What you can do is, instead of the LFO, we use a Seek 3. And I'm going to show you the technique, but I'm not going to do the whole thing because it does take a little bit of time. So the technique here is, I'm going to turn that down. And I am going to throw another VCO here that we're just going to, we're at the end of the day, we're going to throw this VCO out, but we're going to need it for what we're doing. We're going to take row 1 and pop it into the, oh, not what I wanted. Sorry. Let's try VCO number 1. And we're going to pop row 1 into volts per octave here. That's our pitch. And we're going to take the sine wave out, and we're going to pop it into channel 2. And what we're going to see, I'm going to slow the clock way down. And we're going to go, right now it's on step 2, I just saw it flash, and I turned off run. Okay, so that's fairly interesting, right? I'm going to bring this down just a tad. All right, so we got something interesting there, and the reason you use a tuner is you can really dial in your scale this way. So what I did, and I can't do it now because I'm in headphones, but what I did previously in the patch that we'll bring up later is I just took the tuner, popped it by the speakers, in a way that I could see it, and then dialed in the tones that I wanted. So the next thing is, we know that we're getting our control signals out of here that we want. So we're going to just pop that into the input here. We don't need this VCO anymore. And now we've got 2 separate clocks going. I've got the clock on the Seek 3, and then I've got the clock on this Seek 3, the one that's actually doing the triggering. This one is going to be cycling through the various tones that you've created here. Now, there's no way to get a random step, but these 2 clocks aren't running at the same rate. So now you can see with that sample and hold, you've got, you're grabbing a control voltage from here at a certain point in time. Whenever there's a trigger from this Bernoulli gate, we are getting that, where the sample and hold is saying, hey, grab the control voltage from the input and pop it onto the output and keep it at that level until we get another trigger. So now you've got a nice scalar thing. And this isn't quite as scalar as I would like it to be, but, if you sit down with a tuner for about 5 minutes, you can easily get 8 steps, or 8, 8 tones at the proper control voltages here, to kind of make something really nice. And you can do multiple voices this way. So I'm going to show you. So this is the basic technique. And I'm going to, before I move into the, the patch that I baked ahead of time, let's just go back over what we did here. So we've got a Seek3 that's generating a gate every time we come around. And we're popping that into a Bernoulli gate, which is basically suppressing all but a certain number of gates. Every so often it opens up and it lets something through, and that's configurable with this knob here. We're using another Seek3 to generate our pitches, and that's going into a sample and hold that is run by the Bernoulli gate. That's going into the VCO. We're using an ADSR and a VCA to control the synth voice so that it's only going when the gate triggers. And then there's a delay and a spring reverb here that gives it kind of that nice, that nice atmosphere. That's just going into a mixer, which is going into a multiples, which is why we get stereo output. And there you go, Bob's your uncle, right? It's not super complex, and you can see I don't have a whole lot going on here. It's not like I have, 52 patch cables going. I mean, I think this is less than 10. So you're not really going too nuts. The attenuverter we don't need anymore because we changed out for the Seek3, and the scope is extra. I mean, that's just the scope to see what we're doing. So it's really not that hard to get generative stuff out of VCV Rack. And as you notice, this is mostly, I think 90% of these are like fundamental. These aren't even, there's a couple of audible things in here. I mean, the Bernoulli gate is what makes it work. But the Seek3, the VCO, the ADSR, the VCA, the delay, the mixer, those are all just fundamental modules. The Bernoulli gate's the only kind of oddball thing that you need to kind of make it work. So anyway, I think that probably answers some of those questions about generative patches and stereo output. Now I'm going to go into my patch that I built ahead of time and show you kind of how that works. It's similar to what you're seeing here. And I'm just going to go open VCV Rack 3.2. Alright, so this is the patch that I kind of pre-baked, and you're going to see that I did a lot of the same stuff here. Here's a Seek3 into a Bernoulli gate. I threw that into a cloud generator that I used a tuner on, so this is all tuned into a way, into kind of what I want it to be, the tone that I want. And that's into an ADSR, a VCA, a delay. I mean, it's the same thing we just did. It's almost literally the same thing. Just swap out the cloud generator for a VCO1. And when I bring that up, that's actually on channel 1. So you can hear what we've kind of got going on, which is that kind of fundamental bass drone. Oh, and yeah, I kind of forgot. Voice number 2 is this here, and it's also going into the same reverb, which is why you're hearing it with voice 1. I just didn't want to add another reverb, which I ended up doing anyway, but that's another story. So voice 2 is essentially this here. And we're doing a similar thing, a gate into a Bernoulli gate. We're using an LFO here to drive a couple of other things in the synth voice from the modal synthesizer. It goes into a delay, into the reverb. It's the same basic technique I just showed you guys. And then this is the last voice. And again, the same technique. And these two actually have the same kind of thing that I showed you in terms of tuning the Seek 3. So I actually tuned these first 4 knobs here to it's like a C7 chord is what the tones actually spell out. And then that's just into a Bernoulli gate. We just, we're grabbing from row 1. I've got this into an attenuverter. If I remember correctly, this is slightly offset. Or if it's not offset, you can use the offset as a transpose. So you could actually use a similar... You can actually go in here and like set this to a, like right now it's a 7 chord. I could make it a D7 chord if I take the offset and move it up a little bit. So I've taken the offset. You can hear that it's transposed it a bit. So that's one interesting thing that you can do in VCV Rack that you can't really do anywhere else. Like on a real Eurorack system, you couldn't really do this. You can duplicate a module. So I knew I wanted to use, the same kind of tones in 2 different places. So I actually just duplicated this. And then I could run it through an attenuverter and a different Bernoulli gate, It's really up to you kind of how you want to use this stuff. But this is all pretty straightforward. So I have posted this patch on patch storage, and I'm going to put a link in the show notes. So go ahead and take a look in the notes. You can download the patch. You can play with it. I will also put a link to what we did earlier. I'll rebuild that patch real quick. I'll put a link to that as well. So you can have a basic version of this you can download and play with. And then you can also download this, which is 3-Voice Gen, it's called. And you can mess around with this as well. As you can see, again, it's not super, super complicated. There's not a ton of patch cables in these. And in this particular instance, I didn't even use the sample and hold. That's another thing you can do, that we did in the example. So hopefully this was informative. Let me know in the comments. I'm sure you guys have questions. You guys have comments. I'd really love to hear from you. Let me know what you want to see. Let me know what I missed, or maybe there's a different technique that I don't know about that you guys have figured out. I'm really interested in finding out and exchanging some information with you guys. I think it would be amazing. I'm really, really excited about VCV Rack. I think it's a really cool program. I love working with it. I love making stuff in it. Yeah, I hope that answers everyone's questions. And thanks for watching. I'll see you in the next video.